Hello Lucy. I'm afraid I don't have my webcam so you won't be able to see me, but hopefully this will work just fine. Alright, I've put your questions on the screen and I'm just going to go through them and I hope that helps. Alright, first question is, determine the total profit gained by selling X bikes. Alright, here it costs the bike shop a total of $475.80 to make X bicycles. And then each bicycle can be sold for that amount of dollars. So very simply, I guess here, profit is going to be equal to the amount of money you get from selling the items. So the revenue, that's the amount of money you get from selling the items, subtract the cost of building them all, or making them all. Or here, the profit is going to be 254 take 3x times x, because x is the number of bicycles. So selling X bicycles and they get this amount for each bicycle. Subtract the cost of making them. So the cost of making them is this 475 plus 80x. And that would be enough to find you the correct expression there. However, because it's not yet fully simplified, we really should try and simplify it further. So to simplify this further, we're going to expand and simplify. And that looks like moving both of those for x. So that's 254 x take 3x squared take 475 take 80x. And we could rearrange that if we wanted to. But really the only thing we need to do now is to collect like terms. So that's the 254 take 80 and 254 take 80 is 174. So take 3x squared take plus 174x take 475 is the total profit when, well, actually, that's an expression for total profit when selling X bikes. Here we want to find out when selling 20 bikes. So do we P equals minus 3 bracket 20 squared plus 174 lots of 20 minus 475. And whatever that is your answer. Right. Find the number of profits a bike sold in order to make a profit of 725. Well, there we will do 725 equals minus 3x squared plus 174x minus 475, and then we solve for x. So we can solve for x a variety of ways. One very simple way would be to grab our calculator. So calculator is the next way to solve for x, just put it inside solver. Alright, find the maximum number here. Now, here I would use your calculator. So let me just bring up the calculator. Memory 5 minus 3x squared plus 174x take 475 equals. Now our view window is going to be miles out. We'll want to go to say at least 100 bikes. And the profit might have to go to at least say 2,000. That's just a guess. We'll see how it looks. Oh, not bad. Shift view window, let's go beyond 2,000, 2,500. Alright, so let's actually do this question just before, this one here. To do that one, we'd throw this in the calculator. And the other way we can do it is we can put 725 here and draw that. And we can see that the number of bikes they could make is either 8 bikes or 50 bikes. Either one of those solutions would work for this. So x would either equal 8 bikes or 50 bikes. So when they made those number of bikes, they would have a profit of 725. In order to make the maximum profit, you go Shift G-solve max. And the max of that is 29. So when they make 29 bikes, they have a profit of $2,048. Alright, so calculator is extremely useful there. Moving down. Alright, calculator is going to be quite useful here as well. Let's delete these. and enter in a new equation. 4 plus sine pi times x divided by 4, close bracket. Alright, shift setup. I want to make sure I'm in radians. Excellent. And view window, I want it to be trig. I want time to be between 0 and 8. And then looking at the y values, this will have a low y value of 1, but I'm going to set it at negative 0.1, just so I can see the x-axis. And it'll have a high value of 7, but I'm going to set it as at 8. Alright, lovely. Now, we want to find the initial population. So the initial population is right here, where it starts off at times equals 0. So we can look at the y-intercept. The y-intercept is y equals 4, which means the initial population, note in thousands, is 4,000 bugs. Alright. The largest and smallest populations. Well, we can show shift gsolve max. So that's 5. Largest population is 5,000. Shift gsolve min. Largest population is 3,000. Sorry, smallest population is 3,000. Something's gone wrong. It's because I've entered the wrong equation. Hopefully you spotted that before. There should be a 3 there. That's more like it. Max, 7,000. Min should be 1,000. There we go. Alright, find the intervals in which the population exceeds 6,000. So what we can do is we can put a line of 6,000 in, and we want to find when is it above that line. 6 rather, because it's in thousands. Alright, so it's above that line between time equals 0.93 seconds, or 0.93 weeks rather, and 3.07 weeks. So that's the time interval where the population is above 6,000. Alright, finally here, this is very similar to the investigation. So in the investigation you needed to find a trig model, and your trig model would have looked something like this, where you had amplitude, period, horizontal translation, vertical translation. All of those variables fit to a graph, and that's what's happening here, in that you need to fit all of that by hand to a graph, exactly like part A of your investigation. The other way to do it is to let January equal 1, like you've done down here on the axes, excellent, and enter that into your calculator, and then press into statistics mode into the calculator. So in 2, down here you go like 1, 2, 3. Ooh, I won't do it all, I'll just do the first 3. 14.5, 14.5, 13.2, exit, graph 1. There's our first 3 points. Then what you can go is calc across sine. And it won't let me do it because I don't have enough points, but it will let you do it. If you press that sign, it will give you the equation of a curve that would work perfectly. Alright, I hope that helps. Please, send me more questions if it doesn't.